The Chapter 6 practice test here that you see in front of you. I will zoom in just a little bit here. Remember, you can stop the video if you need to write anything down as I go over things. So on this first one here, we see we have 3 to the power of 0. And hopefully you do remember that anything to the 0 power is 1. And that's except for the number 0, but as you've seen, we haven't had to deal with that. So basically, anything to the power of 1 is 0. So if you want to write that as part of your notes, go right ahead. Anything to, let's just say 0 power, is the number 1. So you would just say something like this, and that is your answer if you want to put it into a box. Number 2, we have the same base, which in this case is a 5, which means that we can go ahead and add the exponents. So it would become 5 and then negative 6 plus 3. Well, negative 6 plus 3 is going to be negative 3. But you can't leave an answer with a negative exponent. It says we can only have positive exponents in your answer. So what I'd like you to do with that is to go ahead and write the reciprocal. So we're going to move that 5 to the bottom of the fraction, and then this negative 3 becomes a positive 3. I'm okay with you leaving it like that, or if you want to be a little bit more specific, you can write what 5 to the third is, which is 125. So that would be your answer. On number 3, this is one where you have to remember that the 3 exponent here applies to both the negative 4 and the x squared. So I would write it like this, negative 4 to the third times x squared to the third. So once we've done that, you have to figure out each one of these. Now this does mean negative 4 times itself 3 times. So negative 4 times negative 4 times negative 4 is going to be negative 64. And then over here, when you have a power to a power, we multiply those. So it's 2 times 3. 2 times 3 is 6. So that would be your answer there. We're multiplying power to a power. Finally, on number 4, we've got a couple things going on. We have a negative exponent, so that means, well, right away, let's just flip this whole thing. We would have now 3a to the third on the top of the fraction and a 1 on the bottom of the fraction, and this negative 4 becomes a positive 4. Now, if you have a 1 on the bottom, you can just really ignore it, so that will become 3a to the third raised to the 4th power. And now it's a lot like this problem right here. So I'm going to write that as 3 to the 4th times a to the third times the 4th, or not times the 4th, raised to the 4th power. So this right here would be turning into an 81, and then we multiply these exponents, so that'd be to the 12th. Okay, moving on to these next 2 sections. They do tell you basically that this is going to be a geometric sequence because it talks about a ratio. So we already know that. So you do have to remember what that's going to look like. Notice we have to write down both a recursive rule and an explicit rule. So I'm going to put this up here just for a second. So we're dealing with geometric, and here they are. If you need to pause the video, go right ahead. But those are the formulas that we are going to need. Remember, R stands for common ratio. I'll put that back to the side. So to get what this ratio is, if you can't spot it, just take 2 of the numbers. So you could say, well, 6 divided by 2, that's equal to 3. Well, that's my ratio right there. Put a little box around it. Okay, so for the recursive rule, you saw what I needed to do. So recursive rule, you always have to say, what is that first term? Well, they tell us. It's a 2. So a sub 1 is equal to 2, and then we have to know where are we going from there. So to get the next term, we have to multiply by 3 the previous term. And this right here means the previous term, a n minus 1. So we would take a 2, multiply it times 3, we get a 6. And then we would take the 6 right here, multiply it times 3, and you get 18, and so on. So the explicit rule. On that one, we don't have 2 parts, we just have 1. So a sub n would be 2 times 3 to the n minus 1. Okay, that's it. That's just asking for the equation. And I think I will go ahead and put in some stuff up here. So we need a sub 1, which is the first term. And then the second part was a sub n is equal to r times a n minus 1. So that's what we did for this one. And for the explicit rule, we filled in this. Okay, so I'm just filling in what these numbers are. Okay, first term and what the r is, what the common ratio is. Now for the 10th term, I'm just going to go ahead and take this explicit rule and take a sub 10 is equal to 2 times 3 to the 10 minus 1. You'll want to put that into the calculator because it's kind of a big number. And you're going to get 39,366. Okay, so I'm going to do a very similar thing right here. So this one, we are going to be dividing again. Now remember, we divided the second number by the first. So 84 divided by 112. So if I put that into my calculator, I'm going to get 0.75. So that's my I want to say radius. That's my ratio right there, 0.75. So for my recursive rule, I have to do these same 2 steps. I have to say where we are starting. So that's a sub 1 is equal to 112, my first term. And then I'm going to have, what are we doing after that? Okay, we have to multiply it times 0.75. And then we'll have I'm going to put the dot right there, a n minus 1. That is my recursive rule. Where am I starting, and how do I move on? I multiply it times this. The explicit rule, you can see the basic one is up here. So I'm going to write that down. We have a sub n. We just need to plug in the first term, which was 112, and then multiply it times whatever the r is. And I wrote this a little bit too big, so I should have an n minus 1 right there. Now in this one I have to get the 8th term. So a sub 8 is going to be 112, and then I'll have the 0.75, and then, well, over here you saw it was n minus 1, so this will be 8 minus 1. Put that into the calculator, and you'll get, I'm going to change this to approximately, because this one ended up being not an exact number, so I'll say 14.95. All right, moving on to the last 2 on this page. It says to determine whether the table represents exponential growth, exponential decay, or neither. So basically, we have to just look at what the y's are doing. Okay, you could ignore the x's right now. So we're just looking at the y's. So we have to know if there is a common difference, a common ratio. Actually, let me just take that back. This is exponential growth or decay. So it's not going to be an arithmetic function. They're saying basically what kind of geometric function is it, or is it neither? So I'm just going to kind of take a look at this and see what's going on. So 2 times 4, that would be times 4, but this is 8 times, that would be times 3. I could stop right there. Okay, it doesn't really matter what this one is. These are not the same. So this one is going to be neither, and that's because there's no common ratio. Okay, and over here, Well, 40 to 20, that seems like half, so we must have divided by 2. 10 is half of 20. We divided by 2 again. And then 5 is half of 10. We divided by 2 one more time. They are going down, so that one is exponential. I'm just going to write EXP, decay. And R, yes, we are dividing by 2, but that means 1 over 2 is what R is. Okay, flipping over to the next page. So on this section, we have to decide if the sequence is arithmetic, geometric, or neither. So remember, this one is add or subtract. This one is multiply or divide. And when I say that, it has to be by the same thing. And then if it's none of those, it would be neither. Time a little bit. So 9, 10, 11, and 12, you're just looking to see what is happening between the numbers. So you can see what I wrote. We're adding on this one 2 at a time, so it's arithmetic. The common difference was 2. This one, multiplying by -2, so R is -2. That makes it a geometric sequence. This one is neither. You know, it's +5, +7, so this is neither. There's no common difference or ratio. And this last one, we're dividing by 2, which does mean R is 1 over 2, and it's geometric. All right, moving on to this next section, we have to plug in these numbers here. We're seeing what x is equal. We have to put it into the equation, and you can do this by hand, or you can use your calculators to come up with the answers. Look at that. Pause if you need to. This one, by the way, I could have spent a little bit more time with, but this would be 1 over 0.5 to the 4th, and then it does turn into a 16. Put it into the calculator and see for yourself if that looks a little weird. All right, then we're going to go to this last section here, and it says determine whether these functions represent growth or decay, and then explain why. So basically, we have to look to see what is the number, what is our base. It's in the same position as the R. So I'm going to highlight what that is on all of these. So I need to just look at the numbers that I'm highlighting. Okay, I kind of wish these had some parentheses, but I'll change that later. So if that number right there is bigger than 1, it's growth. And if it's less than 1 but greater than 0, so I'm going to say between 0 and 1, it's decay. All right, so growth if it's larger than 1, and then I'll switch colors here. So the other one would be decay if it's between 0 and 1. Okay, that's really all we have to do. So this one, 0.9, well, that's going to be between 0 and 1, so that one would be decay. And you could just write the word decay. For the y, you could just say that this number is between those. So you can say, you can call it, we've been calling it R, so why don't we just keep on doing that? We can say, the fancy way, we'll do it this way. Okay, you could write out R is between 0 and 1 if you want. Okay, this one over here, 5 over 3, well that's, 1 2/3. That's bigger than 1, so that one is going to be a growth answer. And then you can just say R is greater than 1. Once again, you can write out those words if you want to. This one right here, 1/3. That's going to be decay. And it's the same reason over here. R is between 0 and 1. And then finally, 2.1, that's bigger than 1. So it's going to be an example of growth.